Hi everyone, we are Group 3. Today we are presenting our project about focusing COVID-19 growth with deep learning methods. Understanding and predicting the evolution of COVID-19 diffusion has become of primary importance in United States. Our project goal is to use deep learning methods we learned from this course to build predictive methods from Google search data to predict the state-level COVID-19 cases and deaths in US. We have two data sources. The first one is JHU COVID-19 measures, and the second one is the Google search activity about the COVID. And also through EDA, we found the most representative 10 Google Trends terms. And these 10 terms are quite related to the confirmed cases trends in California, Massachusetts, and New York. Next. Our primary outcome is the JHU cases and deaths. And in order to have better performance in our model, we first try to cluster 50 states across United States by their pandemic growth patterns. Therefore, similar states will be implemented similar models. Next. There are 39 states in cluster 1 and 11 states in cluster 2. We also used June the 5th, 2021 as the cutoff, before which served as trend set and after which the test set. In both trend and test sets, we use 14 past days data to predict the following 7 days cases.
To achieve our goal of predicting COVID-19 cases and deaths, we try 7 different neural network structures. The first one is conv_NN. It's a 2 convolutional 1D layer followed by a flattened layer and 3 dense layer with value activation. Then with a dense layer with linear activation for model output. And also we try to use simple version of RNN, GRU, and LSTM model. And we try to analyze the counts in both directions. And therefore, we also implemented 2 bi-directional layer version of RNN, GRU, and LSTM called bi-RNN, bi-GRU, and bi-LSTM. And note that the simple RNN model has significantly smaller number of parameters compared to all the other models. We trained our neural networks with root mean square error loss. The optimizer is set as Adam with a learning rate of 10 to the minus thirds, and early stopping with patients of 3 was used to prevent overfit. And we use 4 model evaluation metrics. The first one is called Pearson correlation. It measures the strength of the linear relationship between the predicted and actual value. Second one is root mean square error. It can be viewed as a L2 loss function. And mean absolute error, it can be viewed as L1 loss function. And it is robust to outliers. And the last one is symmetric mean absolute percentage error. It measures the accuracy based on percentage errors.
So next, we show the result of different models. So in both cases prediction and depth prediction, we can see that recurrent neural network outperform all other models in most of the 4 metrics. Next. So here we show an example of recurrent neural network to predict the cases and deaths in Massachusetts. We can see that the recurrent neural network model can learn the curve of deaths and cases effectively. Next. So here we want to discuss the limitation and future work of our model. First, the relevant Google search term may change as the pandemic progresses. Secondly, the predictions rely heavily on the accessibility of training data of several days before the prediction. In the future, We will consider spatial temporal correlation in the COVID-19 spread and external factors. We will also consider Bayesian neural network model, generative adversarial network, etc. Next. So in the end, we can see that the winning model of all is the recurrent neural network with one layer. We also showed that the Google search and data is helpful in forecasting the future number of COVID-19 cases and deaths. Thank you.